All right, everybody, having a great build so far here in the last session of the last day? That sounds like, oh my God, I need more coffee. All right, so the formal title of this session is Surviving Success, Performance Tuning Under Pressure. But what this really is the day when this happens. So who's had this experience? The site, the app, the thing is slow, people are angry. So for those of you who don't know me, I'm an architect on the Azure Customer Advisory team. My job largely breaks down into three things. Today's session is all about when I get thrown on an airplane to go put out a fire. And what we wanted to do was take you through a little exploratory walkthrough of the day in the life of fixing a live site issue that is performance related when you know nothing about the system and have never seen it before. Sound like a bit of fun? All right, so some ground rules. This is going to be about make fast now, but no breaky when you don't know anything about the system. I'm going to walk through a completely contrived, utterly fake, but inspired by real events application with some real bugs baked in. And it's going to be all about how do we make data-driven decisions under pressure without breaking things on live site. So this is intended to be technology agnostic. I'm going to do everything through the lens of an application because I wanted to learn some new stuff. If you're not familiar with Docker, containerization, Swarm, .NET Core, don't worry about it. The focus is not that tech. Everything here is in a GitHub repository listed on the bottom. Feel free to kind of play along from the audience. And anything I do is fully scripted, so you can do it, basically do it from the comfort of your own Azure subscription, except for I hard-coded a few things I haven't changed yet. And all of the monitoring we're going to be looking at today, because Azure is an open platform, and I wanted to show some options, will be based on the Influx, Grafana, and Telegraph stack. If you've never seen it before, you're going to get a little hands-on view today, and feel free to check it out later. Some ground rules. This is meant to be interactive because it's the last session of the last day, relatively small number of us. We can all be friends. Please use the microphone, as this will be recorded. And let's just go on a little journey together. Sound good? All right. So every journey starts with where we are. So T at 0 hours, customers and leadership are riled up. The site is slow. This is unfortunately the starting point for a bad day. But let's walk through a process and make it less of a bad day. The very first thing we always want to do in any situation like this is really just establish current state. What do we know? How do we know it? And the key thing is to get all the folks involved in the room. A lot of the escalations I've been brought in on, there were just symptoms, and a root cause was all the business units were not in collaboration. I was actually talking to someone this morning at the clinic that we run here to kind of like walk through architecture, where there's just these big barriers between different business divisions, between IT and marketing and business. And if the first page in your triage and remediation process is not get every single person who, basically every stakeholder or every kind of role in the room and talking and sharing information, anything else you do is probably either going to be luck, happenstance, or pain. So generally when I go through, basically the next slide is going to be what's written on the whiteboard. It's going to evolve throughout the day. And it's all about establishing what do we know? Do we know what success looks like? Do we know how customers feel? Do we know dashboards and design documents? Basically, what are our sources of data? And just list them out. What do we know about the current situation? More importantly, how do we know it? Is it documented? Was it a conversation? Was it a Twitter thing? Was it actual data? And if you've got data, where did it come from? When was it captured? How was it analyzed? Because unfortunately, data is going to tell lies in the heat of the moment. So we just need to understand where our data is coming from and what we do with it. From there, it's all about what do we think is the problem? One of the most unfortunately common reactions to a crisis is to move swiftly and with confidence, but without data. I'm sure we've all been in the diagnostics and thinking, well, it could be this. Let's go try something. Absolutely. It feels like the right thing to do in the moment. But the theme that's going to go throughout this presentation, and in the 100 to 150 times I've had to get on a plane in the last 5 years to go sort out a critical issue, it's always want to be in the realm of slowing down to move faster. It's like running a marathon. You want to tie your shoes before you start going 13 or 26 miles. All right. And a lot of times there can be multiple hypotheses. It could be this, it could be this, it could be this. You could try all of them. Time-consuming, and sometimes you change 6 things and you don't know what's been changed. Or we can get down to what experiments are we going to run, or how are we going to get more data to help choose between them. So we're going to go through this process a few times through the lens of a fake application, and get some insight. All right, so my utterly contrived application is a back-end system for an in-game raffle with hourly prize giveaways of digital assets and has experienced sudden and amazingly awesome success. A thing we don't talk about much as an industry is failure is easy to survive. Nothing happens. But success is so painful because you're so close to victory, but all of the engineering debt, all of the things you were going to get around to, all that debt gets called home in one sudden day. And the thing that's particularly interesting is I've kind of crafted a class of application that is very vulnerable to either spike mode or viral events, where basically huge numbers of folks will show up at the same time, and you may not know about it in advance. About 80% of what I get called in on are spike mode or viral events, especially if you're in a small shop and you've never had basically to deal with 1 million users showing up at once before. So part of this is just going to be how to survive that without having to fix everything, because that's not practical. All right, so the site is slow, or it's broken, or it doesn't work, or it feels funny. Qualitative, emotionally focused statement. It's perfectly valid. At the end of the day, we're looking to deliver value and we want our users to be happy. But that's not actionable from an engineering perspective. There's nothing in there that lets me know when it's not slow. Without knowing what fast is, I can't formulate a plan. Without knowing whom it's slow for, it could be slow for everyone. Well, that's bad. It could be slow for a subset of users. It could be my high-end premium users. It could be my not premium users. Or in the case of one time I had to get on a plane, the only user that was affected was the chairman of the board. I still got on a plane. It turns out it was his ISP in Malibu. Go figure. All right, so what is slow? Is it the server, the back end, the user interface? Modern applications are highly distributed, running across a lot of different places, often built by multiple organizations. Not just the components and the tools, but APIs. I'm going to have a lot of plane stories here, because nothing ever seems to break in Redmond that I can talk about. So I get on site, and they had kind of a massive outage. And of course, the rule being, if it happened in Azure, it's obviously our fault. And sometimes it is. But in this case, what was happening was the authentication provider was calling out to a third party, and that had had a hiccup, and that had backed up and crashed the whole site. So in this case, the mobile app was running great, the back end was running great, but there was a transitive dependency that had tipped over, and it wasn't instrumented. So knowing what does slow mean, very important. So let's frame some success. All right, first try. The site must respond to all valid operational calls within 500 milliseconds. Sounds great, right? Obviously, this is a trick question. What's wrong with this? If we had to sit down and say, you must deliver this, badge on the table, what's wrong with this statement as it's written? Well, let's go through. 100% adherence, that means no one can be on a mobile phone and go into a tunnel because you're not at 100% anymore. Flat latency definitions, everything being under less than 500 milliseconds, that's a very expensive starting point. And the best part is there's no scale target here. This basically asserts that you're signing up for infinite scale, which sounds great in marketing material, but we're dealing with some physics here. So let's go with something a little bit more realistic. Let's say that our site must respond to 99.99% of all valid operational calls within 500 milliseconds at the 90th percentile through 25,000 requests per second. We can test for this, we can measure for this, and we can hopefully build it. But anytime you're in a performance remediation, if you can't get to a statement like this, it's just going to suck. There's no more polite way to put it than that. You will not have an actionable, achievable engineering objective without covering success rates, throughput, latency percentiles, and the workloads that it covers. And if you're kind of the business owners can't derive down to this, you got to solve this one before you can move on. All right. Again, this is still not perfect. It doesn't talk about which workloads, it doesn't talk about which aspects of the system, but it can be our first goalpost on the journey. You don't necessarily need to know with 100% crispness the end of the journey, but you must know the next step. All right, so what do we know? We know that that's our SLO, and how do we know it? Our business owners told us, and they're signing the checks, so that's pretty good data. The site is slow. How do we know it? Twitter storm. Good, okay. And that the application is deployed as a service stack on Docker Swarm using the web apps Redis and SQL. And you know that because the design document told me and I told you, which is often where this is going to come from. You huddle the group together and like, well, the design docs say it's this way, so it must be true. Right, that's our first problem. We have not confirmed that the as-built, what physically exists, is what is documented. This is going to be a common problem. So we need to validate that source of data. We need to stop, take a breath, and go, okay, is the set of variables we think we're working with, is it what's actually on the live site? Because unfortunately, nobody's change management policies are perfect, and I don't know about who's ever gone back and actually really updated a design document when their site's growing quickly, because I'm not putting my hand up for that one. These things get out of date. The only thing that's real is the live site. And also, we don't have enough data to know anything. We don't know how the site is slow. We don't know if it's slow, for whom. We don't know anything. So let's slow down and move fast. And we'll get to our next step on the journey. So hopefully about 90 minutes in, we've managed to get all the right people on the phone. And if you don't actually have in a small company, this isn't too bad because everyone will know anybody. In a large multinational organization, if that live site service doesn't have the list of people from the business units who are accountable and their secondary contact information and their cell phones, this can take weeks, which is a horrifying statement to make, but I've seen it happen, before all the stakeholders who own all the pieces of the app and everything it touches to be able to get in the same room. All right, so we're going to turn on the lights. This is the second step. We know where we need to be, so let's turn the lights on. Let's actually get the right data and know what's going on in our system. Just to reinforce, design documents are largely going to be a work of polite fiction. They're going to tell you lies. These are not lies of malice. They're simply lies of latency and consistency. The only truths you can depend on are live site data correctly gathered and interpreted and code, which means that I hope your ALM systems are good so that you know which branch the stuff in production actually came from. And in the heat of the moment, it's like, well, Joe and Sally know that, and they're both on vacation. This is a problem. Plain story. About a year and a half ago, I got called in on a live site escalation. And we're going through, and I'm like, okay, I'm pretty certain the problem is here. Let's go and make that change, and we should be good. Oh, we can't. The only person with the management certificates is on the side of a mountain. Luckily, he could email them from the side of a mountain. But these sorts of things, success or failure or the combination of both, will expose all of these aspects of the processes that have not been shored up. All right, site telemetry. Unfortunately, this slide has been left intentionally blank, as this is all too likely what I walk into, in that in the rush to put features out, which is perfectly legitimate and the right business decision, the investments in engineering fundamentals, specifically monitoring and telemetry, have not been made. Unfortunately, more than 70 to 80% of the time I get to go get on a plane, this is the amount of telemetry I walk into in terms of what's truly actionable. Because most of the time when folks have made the investments up front, I don't need to get on a plane. So what are we going to do? We are going to get our as-built configuration. We're going to get some key monitoring from that system. And then we're going to, as a group, we're going to reason over it. All right. So the challenges we have to fight with. Stakeholders hesitant to make substantive code changes. Fear is powerful. You've had a live site incident. Upper management is very concerned that these crazy nerds in the basement, that's us, but we're not really in the basement right now, are going to go and make all kinds of changes, and we're going to make the problem worse. Anyone had this fun experience? Because I know I have. And anybody who hasn't, well, you get a new experience to look forward to at some point in your career. And we have little to no upfront investment in application monitoring. For better or for worse, it's just where we are in this context. So our approach, we're going to pull and validate the as-built information just so we know that we're working on the right site and the right service at the right time. And if you have services deployed in a dozen different data centers across multiple clouds, this is actually a fairly hard problem. And we're going to put a pure OSS stack approach today. We could just as easily do a first-party Azure experience on OMS and App Insights, or we could do kind of a third-party SaaS provider like AppDynamics or Datadog. But today we're going to do a pure Docker containerization for no other reason than I had to build it for somebody I'm working with and wanted to use it in the demo. Okay, so luckily, as built is easy. I could show a portal screenshot, but I'm kind of a scripting kind of person, so I'm going to go and I'm going to pull some information to say, hey, yeah, I actually have like 8 of these VMs deployed, and here are the services that are running on them. So I know that's right. But what I don't have is I don't have any information about what goes into my web app and how it comes out. And I get a mandate from management that I'm not allowed to make any code changes without a really good plan, because they're locked down, they're fearful. So it's okay, let's work with that, and let's try a little interesting approach. Is anyone familiar with HA proxy? A couple hands. For those of you who aren't, it's a very common reverse proxy platform or service or application or whatever you want to call it that is used to basically sit in front of a website, proxy incoming requests, and it can do a lot of interesting things, rewriting headers, SSL termination. But the really interesting thing it can do, or one of the interesting things for this purpose, is it has really good logging, such that we can basically log all requests in, all requests out, how long they took, where they came from, and build up some data. And because we're essentially wrapping an eggshell around our application, we're not making any code changes, and we can revert very quickly if we need to, simply by routing traffic directly to the site. And we're going to use Influx, which is a time series data store, and Grafana for visualization to be able to turn the lights on. So, unfortunately, due to time pressure, I'm going to have to do this as Marketecture. But if you guys want, towards the end, when we kind of get through the meat, we can flip down, we can get out of slides, we can get into code, and we can actually walk through this in some more detail. OK, so here's our basic application as is. So I'm going to go, and I'm going to take one of my VMs, because one of the great things you can do in most container orchestrators is label certain nodes as being of a certain type of work. And we're going to use that capability in Swarm to say, these nodes, or in this case, one VM, only runs monitoring work, and all of my other VMs run normal work. So one of the things to watch out for is you never want to blend your interactive, user-facing, money-making work and your back-end monitoring work. Because one of the more common things, in the first time you try this, you're going to log too many things, it's not going to be terribly efficient, and you're going to tip over your logging system. If that's isolated from production work, no harm, no foul. If it's not and it's blended, things can get pretty bad. So we'll basically take one of our VMs out of the pool, we'll make it a monitoring-only thing, and we'll add a Grafana and an Influx container to that. And the next thing we'll do is we'll go and we'll drop monitoring agents on all of the VMs to capture host-level metrics and container-level metrics. Depending on the platform, the application stack, this will be slightly different. But at the end of the day, I need to know resources used by all the pieces in the system to know if I have enough of them. And finally, I will drop HA proxy in front of my web app, and I will take live instrumentation from there into Influx and up into Grafana. So without making any code changes, and without making any unrecoverable deployment changes, I can now get real-time insight from what's going in and out of my web app. All right, so T plus 3 hours, we now have a monitoring solution deployed. Without any code change, we're routing traffic through HA proxy. And if I've made a horrible mistake, I can always route traffic directly to the web app. All right, so folks in the audience, if you have your laptops, you get to play along. Because if you go to the link at the bottom, this dashboard is published. So let's go through and actually look at some site data, and we'll form some hypotheses on what can be going wrong. Should have told you there was a kind of an audience participation moment. All right, so let's start off with work being done. So part of what I've got here is, and you can download all these dashboards after the fact and stand them up for yourself. I can see that my incoming requests are actually absurdly low. I'm in the 30 to 40 operations per second. Just for the purposes of this demo, I put a really, really bad bug in the application that triggers at a relatively low volume. Most of the times, some of the more subtle things, they're not going to kick in until hundreds or potentially thousands of operations per second. But either way, there's a nasty thing in here. So okay, so my incoming load looks pretty reasonable. So far so good. But the interesting problem comes right here in terms of my mean latency. So if our SLA is 500 milliseconds, are we having a bad day? I think we're having a terrible day. So we know we're grossly out of SLA, and yet we have now isolated that the site is actually slow. We don't know why yet, but we've confirmed it's not the mobile app, or it's not just the mobile app. we have response times in the 15 to 20-second averages. And averages tell lies, which means that the 90th and 95th percentiles are even worse. So, well, that's terrible. Obviously, I'm a miserable coder and put something horrible in this application. And if we go and we look at the percentiles, they're even worse. If we look at kind of our 90th and 95th percentiles, are creeping up into the 25 seconds. This is just terrible. I wouldn't want to use this app. So let's see if we can't dig in a little bit. All right. So knowing that we've basically instrumented the underlying framework, what are the types of data we want to look for first? Just the obvious stuff, the easy ones. I/O? I/O is a good one. The underlying infrastructure, basically compute, network, and storage. How do we basically have enough of the fundamental resources to run this workload? So in this case, CPU, it's okay, but I mean, 70 to 80% is where things start getting a little high, so that doesn't seem unreasonable. And I probably have a memory leak, but I have plenty of memory on the VM, so it's something I'm definitely going to want to come back to, and that I know my code must be really, really bad if I'm chunking, 40% CPU just for 40 to 50 ops per second. But if this was like 80 to 90 plus, and I started seeing like really strong pushback, it might be indicative that I need more resources. But that's not what the data is telling me. So let's come back out. So latency percentiles, they're crazy. Requests per second, nominal. So let's go and look at the HA proxy data itself. Right. The great thing about HA proxy, since it's acting as an external thing, it's encapsulating from the time a request gets sent to the web app, the time it returns. It's this kind of fully independent, it's not touching it. Depending on how you measure on the box itself, like from New Relic or from even HTTP logs, they're actually measuring things that happen inside the box, not things that happen across. So I can see that my external latency is pretty bad. And requests per second, yeah, they spike, but again, they're not terrible. And that everything is going to this path called API ping. So, okay, we know that at least that API ping controller is really slow and has some form of stacking issue. So the other nice thing that HA proxy will tell me, am my latency delays on connecting to my backend server pools, or because I'm stacking up in HA proxy itself? So I go and I have a look. So this is my queue time. That's the key one to look for. I'm not queuing requests in HA proxy, so I have lots of HA proxy and it's not backing up. Since I said this was for a mobile game or a mobile application, one of the things that continuously connected applications are vulnerable to is connection overload. So if I had an overloaded connection, and basically I didn't have enough front-end capacity, I would see queuing for connections. But I can safely rule that out. So the next thing I see is that the amount of time to talk to the back-end server is stupidly high, and that the time to connect is also stupidly high, which tells me that the response time of that server is becoming very, very poor. Okay, so I haven't made things worse by adding HA proxy, great, and that my service is in a bad state. Yep. Okay, so let's go look at backing resources. Web application, looks pretty reasonable. Not terribly efficient, but not crashing. My front end, this is my HA proxy front end. It's asleep. And that my database and Redis instances are asleep. They have plenty of memory. Memory looks flat here. And that my I/O in and out, again, these numbers don't look terribly bad. And again, my network I/O for my web app looks pretty small. So I seem to have plenty of system resources remaining. Yep, Redis and SQL. All right, so every scalability bottleneck you will ever run into boils down to two simple but very hard things. You either do not have enough of a thing, and a not enough of a thing will generally show itself up as you have linear increase in load, you will see a variable latency and increased error rates, and basically that level will go up fairly flat. So basically, as you hit that tipping point and you run out of resources, things will start to bobble a little bit and then eventually crash, or just not respond at all. That one's easy to, actually, this one's fairly easy to solve, especially in the cloud with horizontal scale. You throw more things or bigger things. The instinctive reaction, especially from certain management chains, will be, well, obviously you need more web servers. Throw more web servers at the problem. And this would be the instinctive reaction, bunch of nods, yeah, that makes sense. I deliberately cooked the demo such that if you throw more resources at the problem, it makes it worse. Because the harder class of problem is when everybody wants the same thing at the same time. Either everybody wants the same local resource or the same remote resource. Everybody needs the same row in SQL. Everyone needs the same lock locally. These are the nasty ones to find and solve because they're hidden. And they only show up under specific conditions. So that's why having the right data is so critically important. Make sense? There's only two things. They're easy, but they're hard to find. Right. So what do we know? We now know that site latency is past 20 seconds, and that latency spike doesn't seem correlated to high levels of load. We're never getting beyond 30 to 40% CPU. And we know it because we measured it in production with 1 second sampling intervals, so it's good near real-time data. One thing to watch out for, especially for like spike mode apps, is if the system you're using to measure data is taking samples in 1 and 5 minute intervals, and you have these quick little 1 second spikes, if all you get are averages, you'll never see them. They'll just get lost in the data. So it's okay to do aggregation over 1 minute windows, but if you don't have percentiles, you'll never see these little transients. All right. Backing resources seem to be pretty good. That's great. All right. So what do we hypothesize is the problem? The usual hypothesis is we don't have enough CPU, mem, network, whatever on the web servers. OK, easy fix. Deploy more of them. It's the obvious answer. And since I already told you, it's obviously the wrong one. More importantly, what we have is a highly variable latency local to the web app nodes, indicative of a contended resource on, and I didn't fix the slide because I changed the demo, on the API ping call. Right. So we need an experiment to validate. Well, normally we would validate these either with profiling, a memory dump, or a code walkthrough. So let's check in where we are on our journey. I'll wait for that. All right. So we're at step 5. We've turned the lights on. We have hypotheses. This is awesome. We know that it could be not enough resources, or it could be local contention. So where do we go? Do we add more web app resources, or do we identify and fix the local resource contention? We have to make this call. We can't do either one of these, or we shouldn't do either one of these, because we actually don't have enough data to really know if we should go left or we should go right. I kind of gave you the answer in advance, and I'm kind of leaning towards the harder one. But when you're doing this live on a system, which you may only know a piece of fairly well, we've got to slow down and get the right data to close off avenues so we can make the right choice. And unfortunately, in terms of these types of contention scenarios, they are hard to find unless you're rigorous about the data. I was actually talking to a gentleman this morning, maybe in the audience, but with the lights I can't hardly see anyone, who has been fighting with a perf issue for months because it only shows up at certain times. And it could be any range of things. But until we drill down and we get the right kind of data from the right perspective, we don't know where to change things to make it better. So what are we going to do? We're going to, apparently we're not going to fix the slide. Oh yes, we're going to basically figure out when we're burning CPU and time on the web app, are we doing useful work, or are we waiting on a lock or waiting on a resource? If we're basically doing lots of good work and the code's just not efficient, no big deal. Add more boxes, make it more efficient later. No big deal. If instead what we're basically is spinning on waiting for a resource, then we need to find that resource and we need to fix it. Right. So hopefully we're only 4 hours in. We've actually deployed a great monitoring experience. We've got production data, we've got hypotheses, and we now know what we need to do to narrow down our next range of choices. So this brings us to where can we get insight from? Right. The usual one, monitoring, high level. Think of this as zooming in on a map. You want to be at the highest level of zoom you possibly can, because the deeper you go, the more it costs to get the data, and the more it costs to analyze the data. So we started from monitoring, going, OK, we are outside of our SLA on throughput, or on latency. Our throughput's not very high, and we have lots of resources left. If we were doing a functional diagnostics for correctness, or we were examining a crash, we might then go to logging and look at exception traces and flows. But today, we started in monitoring, and we're going to go down to profiling, because we need to know what happened. Are we doing good work, or are we contented? And the challenge for doing this kind of on the fly is that there's setup work involved in each one of these tiers from being able to apply these against the production system. Source code, relatively straightforward, but also not very useful without context or where to look, especially for a non-trivial application. Monitoring, and I'll flip it to code in a little bit, because this is going pretty smooth, and we'll talk a little bit about kind of some of the sources, but again, there's work to put it in. Logging, if you haven't logged it, you have to make code changes in order to get that instrumentation in there. Profiling is really great for, I need to basically see what's happening for a time slice in a running system. The downside to profiling is, unless you know how to get to the machine, install and run a profiler, get the profile data back, and then analyze it, that's not fun to learn on the fly with someone breathing over your neck. Little aside, does anybody run fire drills where you deliberately crash an application just to see what happens? You probably should. So one of the things I generally recommend before somebody goes live, and without telling the ops team, because I have a terrible sense of humor, is to go and break the app. Nothing will tell you if your crisis management plan works like a crisis. If you do not induce that kind of failure, you will not find all the little gaps in your process when it matters the most. And a great time to do it is before you launch, or do it off in a QA site and make everybody pretend that it's real. But there's almost always going to be some little gap in terms of a piece of knowledge, a tool, a credential, something. So if you're not doing those today, I highly recommend fire drills. And like I said, the first one should probably not be on a live site, if it's live. All right, so for profiling. Then dumps. Memory dumps are great for a static point-in-time view, but the skill to read them is rare, and there's a morass of data. If I don't look at WinDBG for 2 weeks, I forget everything. So again, that's a very expensive way to diagnose something, because you have to, in production, potentially, break a piece of your system by bringing a node down to get a crash dump, and then get it off the box. Debugging is perhaps the most expensive one, because debugging in production essentially means you're freezing a box. And unless you have a good way to route traffic away from it while you're debugging, your investigative activities are now affecting and bleeding back into your user base. So each one of these sources of information has a different process, a different cost, and a different tool chain that's going to be specific to your application. So you might just run yourself a little health check, thinking about your own apps. Where do we stand on each of these? Do we have a dashboard that everybody can look at? Being really, really rigorous on security lockdowns and your operational dashboard leads to all sorts of fascinating experiences during crises. Like, well, our support team can't look at this data that the engineering team has, and marketing's like, this means nothing to me because it just has requests per second. It doesn't actually also render useful business metrics like number of users and what they're doing. All the way through to logging. Do we log the right things? Does anybody even look at the logs? The easiest way to know if your logging investments are useful, if you've never looked at them, or no reports are generated against them, or you can't index them, you have write-only logs. Great. That's probably not going to be too much fun. And so the good news is a number of the profilers on the market today, at least for .NET, which is the ecosystem I know the best, are actually getting far more approachable than they were a couple years ago. So has anybody used .trace? It's one of the ones I use a lot. I'm a big fan. Not for the reason that they made the experience of drilling down and finding both CPU time, which is expensive code, and wall time, being latency installs. They've made it very simple. So I had to cheat here. Full open disclosure, because these are sorts of things you learn about tool chains when you're breaking things. In order to debug or profile a .NET Core application running on Linux, you need to basically have a certain kernel-level administrative privilege. If you're doing that inside a container, the container, one of the processes in the container needs to have privilege, a specific Linux kernel privilege. Docker Swarm, version 1.13, does not support running containers in privileged mode yet. That was an exciting thing to discover. And you can't just run a container. So Docker Swarm has run this set of containers and run this one container. Running this one container, which you can run privileged, can't connect to the network of the set of containers. Also not terribly well documented, so that was yesterday. That was fun. All right, so we dig in. Great thing about .trace, they have this little button that's called Tell Me About Things That Are Waiting. This is how we do latency analysis. What are we blocked on? We drill in on waiting, and it turns out that, hey, everything in sample web app baseline is locking up on this tracer.log. Well, that seems strange. Why would logging be so incredibly painful? Any hypotheses from the room? Locking? That's definitely a high potential. It's common if you're writing to a thing, synchronizing it works really well during testing and blows up at a certain scale. Contention over file access, that's a really fun one. I've seen that 2 plane trips because of that one. Essentially, one of the common things, if the logging framework you're using doesn't properly funnel requests going down to a single file, and if you happen to be running a web framework that has multiple processes all trying to tail to the same file, they'll stack up. You'll hit that tipping point, and everything will go over. Logging is unfortunately a very common way to break a system at scale. And what's the usual reaction? Well, just turn logging off in production. It doesn't. Oh, wait. So when we were in, 15, 20 years ago, or really even just 5 years ago, when we were primarily on-premise and enterprise systems, the cost of gathering all this data and processing and getting it off box was very high. So we'd run high rates of logging in test and QA, and we'd turn it off in production because we couldn't pay the cost. Carrying that perspective forward to the cloud world is very bad news, because anything that says if we can't run with basically information level logging in production, our logging system's not good enough to tell us what's going on. Or to use an analogy, it's basically saying I'm okay tying a blindfold on and running across the I-5 because until something happens, I won't know about it. All right, so application seems to be blocked up in trace.log. And I've spent a lot of time in PowerPoint, so let's get out of PowerPoint and let's just go look at some code, if my box lets me log back in. And just for fun, I did the whole thing in Linux because none of these techniques, none of this approach is operating system or tool dependent. All right, so we knew the pain and suffering was in ping controller because that's what the profiler told us. Anybody see anything terribly horrible here? Of course not. I wouldn't make it that easy, would I? So Logger is using the Microsoft extensions iLogger overlay, which is a really great thing. If you're not already using it, I highly recommend it. It gives you a common logging abstraction through your .NET apps. But it's a provider model, so something is plugged in behind this provider. Okay? So we might have to go splunking a little bit, and this is where that code review comes in. We're down at the lowest level of the stack, and we only have the static understanding of what code is doing. But at least from Profiler, we know the flow of things, and we know the trail of breadcrumbs to follow. So we have a sense that something bad is happening here when we go and basically set up the Logger factory. I would know that just by doing a global search for Logger factory. And if I come in, I'm going to need to make sure that I do this in my one with the bug still in it. So I go to my logging manager. I go, wait, yeah, we just pulled this out of the corporate repository as it's the common logging standard. Does anybody have the source code for that? Just to demonstrate another kind of common challenge is, folks using NuGet for basically cross-team dependencies? Do you have a version of your NuGets with the PDBs checked in? Have you tested it? Okay, he wins. I've seen this, unfortunately, time and time again, is that you're trying to follow best practices, you want to do the right thing, you want clean separation between teams where they consume in NuGets. If you can't basically debug all the way through and step in debug, however you implement it, the Google way of one repository to rule them all, or decomposed NuGets, again, test with a crisis. Can you actually debug from your team's code into another team's code. If you can't, you've just added hours to days to potentially weeks of pain of how do I get from A to B. So just things to watch out for, things to think about. Can I go and can I follow the chain of breadcrumbs? If you look in the GitHub repo, the only thing that's there is a binary DLL. Yes, I checked it in. I'm horrible, I know. So you're basically in there, you're debugging, and you've hit this wall, and for whatever reason, your basically break glass in case of emergency doesn't have the contact information for the shared services team who are at an offsite in Maui because somehow they're more important. What do? ILSpy, LDASM, you decompile the thing because we're using managed languages and it's enough to get going. So you get in and you find this. Oh. This would have been a way better reveal if we were on the right screen. Okay. You find this. This is obviously horribly contrived. But this is also the exact behavior you get when you put a SQL insert inside of a lock statement. This is the exact experience you get if you basically have a downstream log provider that experiences a slowdown at the exact time your application takes a spike. Complete disaster is rarely one or two things happening at once. It's almost always like 10 completely unrelated things all happening at the same time in a way you never could have predicted. So utterly contrived, but this I have seen in pattern form many times before. A blocking call in the hot operational path or in a common path, and basically with synchronized access to a resource used by all paths. So depending on the version of .NET that's used, there's actually another bug in the code. I'll show it to you, I'll explain it, and then I'll tell a funny story about how I had to rewrite my entire demo. All right, so this is, folks using Redis? Cool. So this is the default. If you look on docs.microsoft.com, this is the sample code you will find, in large part, for getting a Stack Exchange Redis client initialized. I've made a few small changes because on .NET Core, if you don't do the DNS lookup, it explodes. I have no idea why. I just fixed it and moved on. I wasn't that curious. But the interesting part about it is it's using the lazy initialization pattern. Pretty standard, folks using lazy T? So how does lazy T work on .NET Framework Full? Of course, since I've been leading up talking about contention, it's probably an interesting bug in there. I won't bring up the full code. It's buried in the .NET Framework source, but plain story. About a year and a half ago, probably almost 2 years ago now, I'd gotten a call from a customer. They'd been having this intermittent crash for almost 6 months, and they were just a little angry, to be honest, and saying, hey, this Azure platform's terrible because we keep getting crashes. I'm like, OK, I'll be there on Monday. We'll get this sorted out. And the same process we're going through, including basically profiler dumps, and it came down to, hey, there's actually a blocking issue in lazy T. And they were completely indignant. There was no possible way that that issue could exist, even with the data in front of them, because we all lock ourselves into patterns of thinking. It happens. So when I originally wrote this demo, it was basically to have this code contend under heavy load. And I was very firm in my belief that I would be able to trigger a lock convoy in lazy T. Remember that part where I said I did this in .NET Core? Guess what they fixed between .NET's full framework and .NET Core? They fixed the lock convoy in lazy T. So I fell victim to my own belief that a certain bug existed. And it wasn't until I went through this full process, induced load, and took a profiler where I went, wow, no, that bug's been fixed. So funny story, I ended up having to rewrite my entire demo on Wednesday to put a stupid bug back in because my original bug had been fixed by the framework. There's your funny story. But it does highlight a key point, especially when we're talking about critical performance-related things. Lazy initialization is really good when you need a small number of things out of a large set. For example, there could be 1,000 different connections, and at runtime I might need 3 of them or 5 of them or 10 of them. Initializing all 1,000 up front is going to be really expensive, so I use lazy initialization to get the 3 or 4 that I need. If my app uses SQL and Redis, I always need my SQL connection, and I always need my Redis connection. So why am I not instantiating them up front and then passing them in? So how I spent my Christmas vacation in Vancouver was actually fixing a similar issue with a lot of performance issues that were all tied to late binding initialization. If you're writing high-performance code or code that needs to be optimal in the hot path, you generally speaking, always want to initialize everything up front and then just let it roll. So it's one of those patterns are only good in context. Lazy initialization is fantastic for sparse initialization. It is terrible if it's the, I always need this thing. It's not going to be as horrible in .NET Core because we changed how the lock works, but there are other instances of it. Okay, so let's go back to the slides. All right, yep. All right, so we're on our journey. We are now ready to identify and fix the blocking and logging trace contention. Luckily, we're only 5 hours in. And when we walk through and I'm kind of like leaving the trail of breadcrumbs to the next one, it seems pretty simple. It seems pretty straightforward. But when you're doing this in the moment of crisis with everyone looking, there's going to be a lot of pressure just to do something for the sake of doing something. Hold the line. You've still got to make choices, and you've got to make the best ones you can in a short time frame. But you can save yourself an inordinate amount of pain and suffering by getting the right data in the right context to be able to take a few steps forward. You're going to make mistakes. Some of those decisions will be wrong. But then you'll be able to come back and go, all right, we've ruled that out, as opposed to just throwing changes at a system and potentially making things worse. And you might think, well, 5 hours, that's a really long time. But if you put yourself in the perspective of, if something happens right now, how long is it going to take to get everybody on the phone? How do you set up a bridge? And just all the way down that line. Unfortunately, in a lot of cases where I get called in, that's been 5 months because folks were not rigorous about getting the right data. All right, so let's push out our code change with the, we're going to use asynchronous logging. So when I say asynchronous, it's actually fire and forget. Any logging library that basically returns a task, there's probably something really wrong, because all logging, as opposed to auditing, should just be fire it into an in-memory buffer and keep going, and the logging library makes best effort to get it somewhere else. Anything else, it's really auditing, and it's a business activity, and you're willing to crash the workload if you can't, quote-unquote, audit it. All right, so hopefully we're only, we're 6 hours in, our code fix has been pushed to production, and the team is reviewing the monitoring data. There's another engineering system hidden in here. How long does it take you to go from a change in your repo to a production push out with all the checks and balances? If it's like 5 to 10 minutes, awesome. If it's, we think it's a day, okay, maybe that's okay, maybe it's not. But in the time of, again, a crisis will expose do we have the right people and the right procedures and the right keys to calmly go from this branch to a build to validation into production. And if any piece of that involves the portal, you're doing it wrong, because the portal implies that a human needs to click buttons. I don't know about you folks, but I've clicked some very bad buttons in moments of stress. The first major production system I ever personally took down was a chip manufacturing plant at the tune of $150,000 an hour by misconfiguring a Yellow Pages update between 2 Solaris domains, which I just totally dated myself. Basically, automation in times of crisis is going to be your friend. If you find yourself using the portal because you haven't basically taken the time to write the script, slow down and move fast. Stop and write the script. And test it on a non-production system. All right, so a test run. Let's look at a little fix. Let's push it out. And let's see what happens. All right, so we'll go down to our conveniently named version 2 with bug fix. And we'll go to our support, and we'll go to the logging manager. So what I said was, you know what? We couldn't find that shared services team. They're still at their offsite in Maui. We don't actually have time to do things, quote unquote, right. We just have time to do them right enough. Accept the small imperfections on the way to the next step. If we think about pragmatism versus purity, like architectural purity, we want it to be pristine and beautiful and awesome and perfect, versus I want it to be working and up and not incur outrageous amounts of technical debt. So if you find yourself basically having to do something that feels like a hack, it's okay. But think about it from the perspective of, is this basically going to bridge a small gap and we'll be able to basically recover from it easily? Or are we setting ourselves up for really high interest technical debt? I just look through these kind of pragmatic decisions through that lens. And sometimes you get it wrong and sometimes you'll get it right, and it's okay, it'll just come with experience. So in this case, what I decided to do is, you know what? We're hacking this up. We don't have time. I can't find the site. I'm not going to fix the thing and go through a NuGet rebuild. I'm just going to slice it out at this interface point, fix it well enough, and when the team gets back, we'll have a great discussion. We're not going to blame anybody. We're just going to identify the issue, and we're going to calmly, dispassionately make it better. We might make fun of them a little bit, but again, you're all on the same team with your other shared services folks. So in this case, I go, you know what? We have this App Insights thing. We're running in Azure. The telemetry client's pretty good. What am I just going to jam that in there, configure it? And internally, the App Insights client implementation is a ring buffer that is basically just going to be fire and forget. So I turn that on. I push the change out into production with really strong data that says I can make a highly isolated, non-rippling change in one segment of the code and fix this lock so that we can find the next performance issue. And there's always going to be a next performance issue. That's why we started from, this is the next performance destination. If we get here, we are out of crisis mode and we are back into the normal run of things. All right, so let's look at, and for folks who'd like to look along, that dashboard is published. Oh, I'm doing it over here. So we have a little look. All right, so our incoming load, nice steady ramp up to 100 requests per second. That seems pretty good. And yep, everything's still API ping. So a common form of that pattern might be a mobile application just basically saying, hey, what's the version, what's the time, is the endpoint valid, before issuing any other requests. So in the case of our latency distribution, I made a one-line logging change. So I don't know, I think 5 milliseconds, a little better than 20 seconds. You guys agree? Seem reasonable? Most code, or most of the systems I've seen, there's actually a vanishingly small part of the whole thing that matters when it comes to performance. They're going to be the crosscuts. It's going to be logging, timing, orchestration, critical data. There's going to be 1 or 2 business flows that matter. And if you look at the distribution in your call graph, if you've got 300 things that can happen, only 5 to 6 of them are probably really going to matter in production systems. Start with the first one. Fix it, optimize it, get it better. Look at your data. Is it good enough? Cool. Back to the backlog, out of crisis mode, choose the next item on the list. There's never going to be a perfect system. There's never going to be everything's blisteringly fast. We just need to hit the next business target. Very pragmatic. So we go and we have a look at request latency percentiles, because again, we need to make sure that, hey, did we improve the system as a whole, or did we basically say 99% of the time or 98% of the time it's awesome, and that other 1% it's absolutely terrible, and oh, by the way, that 1% represents an entire Marquee customer. The bigger you are, the more these things will happen. And yeah, request latency looks pretty reasonable across the board. All right, crisis averted. It's time to post-mortem, and it's time to look at root causes, not symptoms. As an industry, we are very bad about fixing symptoms without diving down into the, well, why did that happen? Well, in that case, why did that happen? I'm a little nervous now. In this case, the issue was not that the site was slow. The root cause is, somewhere along the way, we hadn't made enough investment in our engineering fundamentals to have a dashboard, to be keeping a constant eye on data, and we weren't inducing load ahead of when it would actually show up in production. It's much easier if the users you disappoint are fake ones than real ones. So really, this was an engineering systems and a budgeting failure. So when you think about if you're running a live site service and a platform that changes release over release, one of the most important decisions you and your management teams will ever make is what portion of your budget is dedicated to engineering fundamentals. Scalability, availability, manageability being monitoring and operations, and security. If that number is not, especially in the early days, 15 to 20 to 25%, a lot of these basically high APR items are going to build up, and they're going to hurt a lot more over time. All right. So, who's heard this quote? Premature optimization is the root of all evil? Has anyone read the full quote? Well, you get to today. The real quote is actually significantly larger, and it's nuanced. So Knuth was absolutely right that most of the time we spend performance tuning, it doesn't matter. You can't even measure the difference. But for that 3%, or whatever the proportion is, of the performance-critical hot path and cross-cutting code, it is absolutely critical that that run as fast as the system needs it to. You will only discover these things, especially if you haven't worked on a lot of different systems. You'll discover them in production. It's unfortunate, but it's reality. We are always testing in production whether or not we actually wanted to, if you think about it. So the key thing is, how do you develop that engineering rigor to be able to find the 3% and identify what's wrong with it and fix it quickly and with confidence and with data? Because the larger the systems get, the harder it is to figure out where in this enormous landscape of things an issue could be, or even what the issue is. So when we're thinking about this quote, remember the important part is actually what is the critical code. When you've been through this a few times, you'll know what the critical code is up front for some things, and you'll discover other ones. All right, so key things to bear in mind. Success will expose your technical debt to the harsh light of day. It's okay, it means you're succeeding, but you have to be able to close that gap pretty quickly. It will expose the breaking strain of your system. Everything has one. Physical systems have them, software systems have them. We cannot fix everything. We do not have the luxury of infinite time and resources. And if you do, I'm interested in talking to you about a job. We need to make targeted and efficient choices to find that 3%. In order to do that, we've got to slow down to move fast, and it's going to be really unnatural, but we need to do it. We need to put the right instrumentation and monitoring in places, the right engineering processes, and let data, not intuition, as much as you want to trust it, guide your choices. My intuition yesterday told me that lazy T was a great bug. The data said I was incredibly wrong. And that was 2 days of my life I won't get back. And that bottlenecks are caused by contention. Either you don't have enough of a thing, locally or remotely, or that everybody wants the same thing at the same time, either locally or remotely. And those contention issues, you cannot fix them by scaling. In fact, you will almost always make them worse. You may kick the can down the road a day, a week, a month, but that will get called due at some point. And in the case of a very specific set of issues, those will, in response to throwing more capacity at it, take you down faster. So it's very important as we kind of evolve all of our abilities in terms of operating systems under conditions of success to get better at working through the data, forming a hypothesis, and being rigorous about the data says this, let's find out if we're right, and if we're wrong, great, we cross it out and move on. I'll just leave you with a little, one of my favorite poems from Kipling, talking about breaking strain. Essentially, every system has a breaking strain at which it tips over. You can find them through load testing and careful instrumentation, or your users can find them for you. And sometimes letting your users find them for you is actually the right business decision. Just be ready with the right perspective when that happens. All right, continues the formal part of this. I just want to cut the recording we can, but I'm happy to hang around and take whatever questions you guys have. All the code, all the dashboards, all the load testing and demonstrated is on that GitHub site. Anything that's not there, not well documented, throw an issue on there, send a PR, and let's just have some fun with this stuff. All right?